Okay, so let's read number 5 together. It says area is the amount of surface covered by a two-dimensional figure. So anytime you're thinking, if they say area or a square unit, make sure you're thinking about carpet on a floor, squares on the floor, how much paint goes on a wall. So you're covering a surface of something. And area is always measured in square units of some kind. So the common ones are square feet, square inches, square centimeters, square meters, square miles, things like that. And then it says, what is the area of each figure? In the drawings below, each square is 1 square centimeter. Now, it might not be perfect, because again, when you copy something, it doesn't always get perfect. But it's pretty darn close. If you put your rulers on there, if you grabbed a ruler, there are each one of those squares is a centimeter. And that's kind of what I drew on the board. So if you look on your paper, what's great about this is you just get to count the squares when they're perfect squares, because they're not always perfect. So when you do this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the answer is 12. But there's other ways to do it as well, and especially if this box was bigger than we saw before, it's 4 by 3 perfectly. 4 times 3 is 12. Length times width. So our length times width formula should also work. So especially if you didn't want to count them all, if you counted how many columns there were and how many rows there were, that is an option, okay? Now, what's the difference in this and this is we got a chunk missing. So you can do some logic, but there's not many to count, but they're perfect squares. So 1, 2, 3, 4, 5, 6, 7, 8 would be our answer. Sometimes if it's an like an odd shape, cutting it into pieces we know. You know, if you think about the fact that this top one is 2 by 3 or 6. The bottom one is 2 by 1 or 2. 6 plus 2 is 8. So again, multiplication can help you do things a little quicker. Now, the last one is just a little funky, but it's not horrible. We're going to assume, for the sake that we can measure it, that this is going perfectly down. Think about if that was a perfect square there. How much of the square do we have in those? A half of it. So this is a half, this is a half, this is a half, and then these are full squares. So we have 3 full squares, and then 2 halves make a whole, so 1 whole. So what we can think about the fact is if we think about the fact we have 1, 2, 3, and then together that makes 4. So how much do we have? 4 1/2. So that one's kind of interesting because, you know, we've sliced through that. And when you're doing things in real life, when you're laying a floor, when you're, you know, carpeting something, when you're covering, you know, the surface of something, it's not always a perfect rectangle or something. But very often they are. Think about this room. Very rectangular. But then, of course, if we're going under the cabinets, there's a little extra space. So they're usually not perfect. There's usually a little extra of something. There's a little something different in the whole scheme of things. Okay. Now let's take a look at number 6. Now, number 6, I didn't see this before, but you will need a ruler. So if you didn't grab yourself a ruler, go ahead and grab yourself one. You are going to just by looking estimate. And then we'll actually practice. So first I want us to just kind of look, how many of your squares, now obviously you want to use the paper one, how many of those squares do you think would fit in here? Okay. What did you think it was? 9. So I would kind of break it down. Yeah, I mean we got maybe 9 in this section, and then maybe 10, maybe 11 total. I don't know. Okay, so here's what I want you to do. So remember, our estimate is somewhere around 11. So let's go about 11, okay? But I'm going to show you how we could at least get a real sense of what's there. Okay, let's chop this perfectly down so it makes a rectangle. So if you have on your paper, if you want to use your ruler and try to make it square in a carpentry sense with a 90-degree angle, and then make your line go straight down from that top corner. So then we have a straight piece that breaks that one piece into a rectangle. And the rectangle, I don't know, if we break it into, it's not quite perfect, is it? Yeah, it's not 3. It's what, 2.5?
Yeah,
Did you get 2.5?
about.
Yeah. So I measured 2.5. Let's see. Yeah, so this is 2.5. And then up and down is 3, so this is 3. Okay. So the area of just this rectangular part is length times width, or 2.5. Oh, I'm sorry. Hello there. That is 2.5 times 3. Okay. Now that is just this rectangular piece. So then we have to figure out what is this. Off the top of your head, or if you go to the front of your packet, can anybody tell me how to find the area of a triangle? Yes?
Is it 1/2 times base times height?
Exactly, 1/2 base times height. So if we can find the base length and the height length of that triangle, we can find the area of the triangle, and then we're just going to add the two together. Okay, so using your ruler, and I'm going to do the same, we already calculated this was 3. This is 3. Okay, so we really just need that bottom little measurement. So let me tell you what I got. You can help me if you got something different. I got 1.5. Did you guys get 1.5 for the little base there? 1.5 centimeters? Using the centimeter part of your ruler, not the inches part, that would be 1.5. So if we do what Jordan told us, the area of that triangle is 1/2 base times height. So we're just going to take 0.5, or you can enter 1/2 into those red calculators without a problem. So you're going to do 1/2, so 0.5 times 1.5 times 3. And the area of that portion is 2.25. The rectangle was just, I didn't really do it, but it was 3 times 2.5. Let me tell you what that math was. 3 times 2.5 is 7.5. And anytime you have different shapes that are connected, to find the total area, just think about the fact what the word total in math tells us. Total tells us to do what to it? Add them together, right? So we're just going to add those together. So 2.25 and 7.5 is 9.75. Now, Easton had said it was about 10. I estimated about 11. So 9.75 or 9 3/4 is perfect, dead on, okay? So 9 3/4 is the answer. I want you to go here. Now, our units, we measured all the lengths in centimeters, and that was a square centimeter, so put your cm with the little 2 on there to indicate that we're using centimeters, okay? So that one, they wanted us to estimate. And then so you can kind of think about how many squares would fit in there. And then to do the actual math, the answer would be 9.75 if we measured accurately. Did you do the trapezoid formula?
I did the lines differently.
Oh, where did you cut yours? Can I see? Yeah, so what's interesting about these oddly shaped figures is you can use lots of different formulas. Technically, that's a trapezoid. We didn't have to break it up. But I find that breaking it into figures we know is sometimes a little better. Oh, yeah, no, that works, yeah. Very nice. Okay, now let's take a look at number 7. Number 7 says, okay, so we got 5, we got 6, okay, 7. Write the work to this problem by filling in the blanks. A woman has carpeting a room that was 30 feet long and 18 feet wide. The carpet cost $1.75 per square foot. This paper is rather old, so carpet does not just cost $1.75 per square foot anymore. Do we know how much carpet is?
The carpet is probably 7-8 years ago, so I can't remember.
Yeah, I don't know. I don't know either. We'll have to look it up. Okay, so it says how much would the carpet cost? So the first thing we need to do is find the area of the room. Now we're going to assume that it's rectangular, so we know that the area is length times width. Length times width. So now let's put in the numbers with units. So our area is going to be 30 feet. Now you can remember, put the little tick mark if you want, or you can put feet, times 18 feet. And then the area, if you do on your calculators, feel free to check me here. 30 times 18 is 540 square feet. So you do want, once you do the multiplication, foot by foot is square foot. So make sure that you put the little 2 there. That means that you would need 540 squares that are a foot by a foot. That's what I thought. If you look down below your feet, the squares on our floor are a foot by a foot. So this room, how many feet by how many feet, Mr. Murphy? Help me guess. Well, we could count anyway, but this room, we could definitely count.
Something like 40-something.
It's 29, I think, this way. Let's see. This is gonna be a little weird here, but. Oh, it's 29 by 29. The covers are a little, but the actual room space, I thought it was close to a square. Anyway, so our room, if you look at the tiles on the floor, it took 850 probably tiles to go all the way under the cabinet. It's about 850 square feet in this room. Her room is 540 square feet. Now let's talk about the cost. If each one of these tiles, we knew the price per tile, that is a square foot per tile. So we could just multiply by, if we wanted to know the cost for the tiles in this room, if we knew the cost of one, you just multiply by the 840 or 850 that our room is. For her, we're going backwards in time, and carpet's only $1.75 per square foot. And so the cost, all you're going to do is take your 540 times $1.75.
945.
What is it, 945?
Yeah.
Thank you. Put your dollar symbol to indicate what it is showing. If there would be any decimals show up in this process, money, I want you to go customarily to the nearest penny, because that's just the most common kind of thing. Okay, we're gonna go to Menards.
Oh, boy.
Let's see how much carpet really is. This paper is pretty old. Carpet is not that. Let's see if we can find. I don't know. We'll go this carpet. So, well, that's industrial carpet. That doesn't help us. Okay, I picked the wrong kind of carpet. Let's go
Look at that cheap stuff.
back. Don't get the gross stuff. Okay, what's this say?
Holy smokes.
Per square foot? I think I must have really picked the crappiest carpet that ever existed. So maybe that,
You
that,
got the
It's
really
on
low,
sale, I think.
like low pile stuff they call it, like
That's a rebate.
the stuff that's like thick and
Yeah.
expensive.
oh, here we go, 320, 284, $4 per first square foot, $4. So we could get crappy stuff for $1.75, but we could get better stuff. Okay, anyway, so just so we have some context there. Okay, so problem number 8. Now, these ones say to do on your own paper. If you're a person that needs more room and you do it on your own paper, I'm okay with that. So if you want a sheet of paper, fine. We just got to remember to staple it to it so I know that you did these problems, okay? So if you want to grab a sheet of paper, feel free to do that for these particular problems, okay? So let's take a look at number 8. Now, we did one very similar. We talked about this room. I want you to try 8 on your own. I'm going to give you a second here to give that a shot. We have a room that's 20 feet long and 12 feet wide. We're going to tile the floor, similar to the tiles you see here on the floor. That's a foot on each side, so each tile is a square foot. What's the area of the floor? How many tiles would you need? So go ahead and do that for me quickly. You should be able to do that one without much issue. You can always draw a picture, which is a good thing to get you started. Can someone share with us what you got? Tommy, what you get?
I got 240 square feet.
Yeah, tell us what you did to get that.
Well, I did 20 times 12 to find the area of the rectangle.
Yep, 240 square feet. Please make sure that all of you have it, not just that it says 240, but you say 240 square feet. Or in this case, because they told us the way the tiles were, if you said 240 tiles, that's okay as well. But again, this is a real life application. If you walked into Menards and said, hey, I want 240, is that gonna be enough information? You always say, I need 240 tiles, I need 240 square feet tiles, I need 240 square feet. We need to always be specific, okay? Let's take a look at number 9. It says a gardener has a rectangular garden that is 120 feet by 80 feet. She is planting the whole garden with a cover crop of ryegrass, and she is supposed to use 1 pound of seed for every 1,000 square feet. First, find the area of the garden, and then you're going to find how many pounds of seed would she have to use. How many pounds of seed would she have to go buy? So first, find the area, then add in and think about how many thousands was in that work, and then give that a shot, and then we'll talk about it. Bless you. Okay, I'm going to have one of you help me, so I will pick on you, but let's go ahead and just first kind of draw out some things here. So we have a rectangular garden, so you should draw a rectangle. I just made it this way because it could fit a little nicer. So it's 120 feet by 80 feet. Okay, so I want to tell you about my garden. Why not? I have 2 gardens. Well, yeah, I have a big garden. My gardens are kind of like that. They're 4 feet wide and 32 feet long. So, if you think about my garden, let's think about the square footage of my garden. So 32 by 4. Yes, 128 and 128. So I have 250 square feet of garden. So, that's my garden, but anyway, back to the point. So, can somebody tell me the square footage of the garden? We're gonna see if I'm gonna pick on somebody else here maybe in a second. If not, we'll come back to you. Chloe, what'd you get for the square footage of the garden? What was the area of the garden? 9,600. Okay, perfect. So that is how many square feet, and she needs a pound of seed that will cover 1,000 square feet. So the next question we have to ask ourselves, how many thousands would that be? Okay. Well, we say the word 9,000 when we read that, 9,600. So we need 9 for sure, right? But we still have to cover that 600. So the technical answer, all you got to do is 9,600 divided by 1,000, and we get 9.6 pounds. Now, here's the problem. What was the person's name? Oh, A. Gardner. Okay. So here's the problem. If you go to Menards and you might not be able to buy 9.6 pounds, you might have to buy. Yeah, you might need 10 pounds, right? You might need to round up depending on how it's sold. Now, some places, like I've gone to get seed, they'll actually weigh it out. So if she was lucky and could go to a store where you could weigh it out, she could buy that 9.6 pounds, but most likely she's gonna have to go somewhere, read the labels, and make sure she gets 10 instead. Yes?
So the answer would be 9.6 though,
Yes,
right? 'Cause you
yes.
said how many
Now, here's the thing.
pounds.
Exactly. So the exact amount she uses is 9.6. Perfect, that is correct. Here's where it might be different. If they added the phrase,
Buy.
yes, if they said the bags come in 1 pound bags, how many bags would she have to buy in order to make it? Then you would have to buy 10 and just have a little left over. Yeah, perfect. Okay, let's take a look at 10. It says a jeweler bought a square piece of thin silver that was 15 centimeters on a side. So you notice that they said a square and they even underlined it. What is the area, or how do we find the area of a square?
Length times width.
You can still do length times width, right? The only thing about this square, I'm sorry, that's not quite a square, is that the length is 15 and so is the width. So you can think of the square as, well, it's just a perfect, lovely, wonderful rectangle. So it's length times width, 15 by 15, perfect. You can also think of it's the side squared. It's 15 squared. 15 times 15 is 15 squared. So you can write it as 15 times 15. Or you can write it as 15 with the little square. Mathematically, it's going to do exactly the same thing. 15 squared is 225. That would be square centimeters. Now, here's the part. It says the silver costs 10 cents per square centimeter. So we want to find the area of the silver. We did. Now we have to find the cost. 10 cents, technically, we should write it like this. Because mathematically, if you just put in 10 and we said that it was, our answer was 2,250 cents, you'd be like, what? So I suggest you always convert cents into dollars. So mathematically, that's how we write 10 cents, 0.10, okay? Okay, so how do you think we could find the cost of our silver? Tommy, what you got?
Didn't you multiply 225 times 0.0?
Exactly, we're just gonna multiply. Now, what's great about multiplying by a tenth It's just gonna move that decimal place over. But you can check on your calculator. If you do 225 times 0.10, you do get 22.5. Now, it's money. So I want you to make it look like money. So always show to 2 decimal places if there's any kind of money involved. So it would be $22.50. So that 22.5 is correct. Notation-wise, put a dollar symbol on there for me. And please always show the cents to 2 decimal places. If you have to round to the nearest penny. So pennies are 2 decimal places. So money, always round to that. When we get to our financial math stuff we're doing, always make sure you're rounding money to the nearest penny when applicable. Okay? 11. You tell me, we've talked about it now for quite a few days, what is the difference between area versus perimeter? Kind of tell me what they mean and how's one different than the other? What is one showing and what is the other showing? Take a second, write out a little sentence for number 11. What is the difference between area and perimeter? I'm going to give you a second to do that one. So I think almost everybody has written me something a little bit there. A few more people are still going, so we'll give them another minute. And then we'll talk about problem number 12. Okay, let's talk about problem 12. It says in problem 8, that was the one about the room that was 20 feet long and 12 feet wide. It was 240 square feet. Suppose you wanted to put trim around the edge of the room. How many total feet of trim would we need? And notice that this is a perimeter problem when you're talking about the trim. So there's trim in our room here, and you could calculate the trim differently than you would calculate the flooring. So go ahead and just calculate the perimeter of that room for me. And then I want you, for the remainder of class, your goal is to get this page done. We've done a lot of these types of things. Find the area and perimeter of your desk. Here it talks about what a square foot is, which I'll draw up on the board. And then estimate the length and width of this room to figure out what we did. Count the squares. It's perfect, this room, because the squares are measured for you. They're 1 foot by 1 foot. Okay? So for the remainder of class, your job is to finish this paper. When you're done, just come on up and hand it to me. And that's for today. Tomorrow, we are going to review for a quiz. We have a quiz on Friday over area, perimeter, measuring some stuff. And I'll tell you all about the quiz tomorrow. So I never leave you kind of in the dark. I always will give you information about what you're going to see on the quiz. So there you go. Do your thing. When you're done, bring it on up.